Hello friends, I am Professor K.S. Tanpure from Zeal College of Engineering and I am standing before you to deliver yet another lecture on one of the major topics, that is Young's double slit experiment. Now before going into details of Young's double slit experiment, let us know what is Huygens principle. Now according to Huygens principle, he proposed, he demonstrated and explained us that light propagates in the form of wave. Means light has wave nature, it is not a particle nature. Secondly, he explained us the concept of reflection and refraction. Then came an English physicist named Thomas Young in 1801. He did lot of experiments, performed experiment to show the interference of light waves. Secondly, he proposed formula to find out wavelength of monochromatic light. Now, in the first case, while performing the experiment, he explained us the interference of light. Now, what is interference of light? What are the types of interference of light? So, interference of light is only possible when there are two waves. When the two waves crosses each other, then we may say that both the waves interfere with each other. In this particular type of interference of light, we have two types. One is constructive interference and second is destructive interference. Now what is constructive interference? When the crest of one wave overlaps with the crest of another wave, or when the trough of one wave overlaps with the trough of another wave, then we may say that there is a constructive interference. Now what is destructive interference? When the crest of one wave overlaps with the trough of another wave, or the trough of one wave overlaps with the crest of another wave, then we may say there is destructive interference. Now let us go into detail of this Young's double slit experiment. Now according to Young's double slit experiment, he has considered this particular setup. Now this setup includes one, that is your primary source, second is your secondary source, and to view the interference pattern he has a screen. Now as which is a primary source, a pinhole is been arranged so that whatever light is coming from the pinhole, it when travels through this particular slit, it gets diffracted. So that is the concept of diffraction. Once it passes from this primary source, it comes across the secondary source. In this particular secondary screen, we have two slits, S1 and S2. These two slits are rectangular slits. The distance between these two slits, that is S1 and S2, is given by D. The capital D is the distance between the secondary source or secondary wavelets and the screen. Now, once the light waves travels from the primary source to the secondary source, once it travels from secondary source, you may find the light gets diffracted. Now, whatever diffraction of light takes place, it takes place individually from slit S1, it takes place individually from S2. Now, whatever the source of light we have, it should be monochromatic source. The sources of light should be coherent sources. These are one of the basic conditions to find the interference pattern. As the light travels from this slit S1 and S2, you may find there are certain arcs of circle. The darker circle consists of crest of the wave, and the lighter or the dotted circles will give you the trough of the wave. So when the wave passes through these two slits, it will generate alternate dark and bright bands on this particular screen. Now how these are generated? The waves generated from slit 1, the waves generated from slit S2, the crest of one wave overlaps with crest of another wave, which is given by these points. I have marked points on the line, which we will find the crest of one wave overlaps with crest of another wave, or trough of one wave overlapped with trough of another wave. While I have marked cross on this particular diagram, which informs or gives information about crest of one wave overlaps with trough of another wave, or trough of one wave overlaps with crest of another wave. So you will get alternate bright and dark bands on this particular screen. Why you will get bright band? Because the crest of one wave overlapped with crest of another wave. So according to superposition theorem, you will get maximum intensity at this particular point. On the other hand, you will get minimum intensity or minimum amplitude at this particular point. You will get alternate dark, alternate bright bands on this particular screen, and the distance between the dark and the bright fringes is nothing but the fringe width. This is what he observed when he considered one source, secondary source and screen, and make sure that the two waves interfere with each other. He again find out the formula to find lambda, that is wavelength of the light. It is equals to x into d upon capital D. X is nothing but the fringe width, d is the distance between two slits, and capital D is the distance between the secondary source and the screen.